In the last minute or so of the previous video, we saw an example that gave us another reason BPDUs may not arrive at their destination. And it wasn't a down cable, it was a unidirectional link where A could send to B, B can't send to A, or as I've got on the board here, 1 can send to 2, but 2 can't send a BPDU back to 1. UDLD helps us detect this. And the basic operation is simple, and it's going to sound pretty familiar. A UDLD enabled port sends a UDLD frame across the link every 15 seconds by default. If something comes back, we have a bidirectional link, all is well. If nothing comes back, we have a unidirectional link, and not all is well. Now that sent UDLD message, sounds like a radio station, lets the recipient know what device sent the message and what port it was on. It's going to have a device ID and a port ID inside of it. And the recipient sends it right back on the same port that received the message. It's a frame and an echo. So it's a kind of ping. It's really a keep alive more than anything else, because when we start to not get those messages back, that's when UDLD really kicks into action. Now, kicks into action is a very relative term here, and here's why. We have two different modes with UDLD. We have normal and we have aggressive. And of course, the two questions that come to mind, how normal is normal and how aggressive is aggressive. Well, when UDLD runs in normal mode, we get a syslog message to let us know about the problem, and frankly, we don't get anything else. That's it. Now, if we run it in aggressive mode, the results are much more aggressive naturally. The port is going to go into error disabled state, and we've seen that with another feature in this section. After 8 sent UDLD messages result in 0 UDLD frames from the remote switch. So when that port kicks into aggressive mode, it sends 8 UDLD messages. If it doesn't hear anything back from any of them, then we got a problem. The reason we call this aggressive, first off, we're shutting down the port. That's pretty aggressive if we don't hear anything back. Now, those messages in aggressive mode are not sent out every 15 seconds. They're sent out every second once a unidirectional link possibility has been detected. So in 8 seconds, that's how long that remote switch has to answer these messages overall, because we're going to send one out every single second until a possible unidirectional link is detected. And then, of course, we need to go in and fix the unidirectional link, depends on what kind of cabling we have, etc. And thankfully, that's really far beyond the CCNP switch exam. However, enabling it and disabling it won't be. Now, you can enable it and disable it on a global and per port basis. And I've seen this be slightly different on switches, but not terribly. Let's see, we've got UDLD. This is the global, of course, because I'm in global config mode. And you can see aggressive, enable it in aggressive mode, just enable the protocol. And you'll notice except where locally configured, because if you wanted to, you could then go in and take it off of certain ports. Message parameters, not concerned about that. If you just enable UDLD, as I'm sure you get, but I'm going to say it anyway, it's enabled in normal mode by default. So if we were going at the interface level, and we'll go back to our friend 04 here, you get port, and then you get enable aggressive mode on this interface, and then just, carriage return, CR. So if you just do UDLD port and that's it, then you're going to be again in normal mode. Now I wanted to show you here, I've seen some switches at the interface level. You'll notice here it's got aggressive and disable and carriage return. So it might be slightly different on your switch model. It's not anything that's going to really impact your test. But again, I have seen it when you do UDLD port on an interface. One of the switches in my rack shows aggressive, disable, and carriage return, and the other one that we just looked at just showed aggressive, and then that was it. So we know the differences between the two modes. That's really the most important part. Also how to enable it globally and on an interface level. And naturally, for anything like this to work, it has to be enabled on both ends, right? I mean, otherwise it's not going to do us much good. But there's a conundrum in there, because if aggressive mode shuts a port down after failing to get a message back in echo to 8 consecutive UDLD frames, and they're going out every second, won't the second port you configure always shut down before you finish the config? You see what I'm saying? Because it's like you go to switch 1 here, you configure it in aggressive mode. Well, then it seems to me like, you've got like 8 seconds to get to the other side of that link. It's like, oh, okay, let me type this in real quick or have it ready to cut and paste. But that's actually not what happens. When you enable aggressive mode on the first endpoint, that port does send UDLD frames every 15 seconds, as we'd expect, but the absence of a UDLD echo from that remote endpoint does not trigger that aggressive 8-second countdown to shutting the frame down at that point. Because before that can happen, the remote switch has to answer back with a UDLD echo, which tells the local switch the remote switch actually has UDLD enabled. If at the very beginning of your config you configure it on one switch, that switch is going to assume that other switches aren't running it. But once it hears that echo, it's like, okay, now I know that one over there is running it. I will shut this down if I detect a unidirectional link. Because after that, if the remote frame stops sending an echo back, the local switch will begin the process of sending a UDLD message every second and can then put the port into error disabled mode in the absence of a response. So that's really the biggest thing. That's the biggest question I've ever gotten about this. It's like, well, if it's going to go into aggressive mode really fast and I got 8 seconds, how in the world am I going to finish my config in time? And that's why, because the switch you just configured it on is assuming that other switches are not running UDLD, and it will not change that assumption until it actually hears back from one of those switches. That is it with UDLD. Very powerful, but very simple. Commands are very straightforward. And really that's true of everything in this section. We just have to keep all of our guards and loop guards and BPDU guards separate, which I know you'll do, and you'll just nail questions about every single one of these topics on exam day. This concludes this section, but it does not conclude our discussion of spanning tree protocol, and we will pick that up in the very next section. I'll see you there.